Okay, so in this video, we're going to do example 2 and 3 using the first derivative test. Example 2, we've actually already talked about before. We're looking at that same function from example 1, and we want to show that it doesn't have any local extrema at the critical point of x equals 0, and it has a local min at x equals 3. So what are the steps to the first derivative test? We've already done quite a few. Step 1 would be to find the critical points. Those are the x values such that the first derivative is either 0 or undefined. Right, and we did that already. The x values were 0 and 3. Those x values, those critical points, are dividing up our domain into intervals where there's only one of two options. The first derivative is either positive or negative there. So at x equals 0 and at x equals 3, those are places where the first derivative happens to be 0. Here are my intervals. X values less than 0, x values between 0 and 3, and x values bigger than 3. Okay, now we do a sign test on the first derivative. That's why it's called the first derivative test. That'll tell us where my function is increasing and where my function is decreasing. And again, we did this already, so I just typed up this nice little result that we did here, right? So on this interval, my first derivative is negative, so my function is decreasing, right? Negative slopes look like that. My function is decreasing. On this interval, my first derivative was also negative. Negative slopes look like that. My function is decreasing. And then on this interval, my first derivative was positive, so my function was increasing. Looks like that, right? So now all we have to do is interpret these results. Since my function is decreasing on either side of x equals 0, we don't have a local max or min. But here at x equals 3, my function is changing, so I don't even need to have my graph. I know something. At x equals 3, what's happening? My function is changing from decreasing to increasing. We must have a local min. F of 3 must be a local min. So let's just write up those results, which we kind of have already. Since f changes from decreasing to increasing, at x equals 3, what must be true? And I was using gray for f. F of c, f of 3 in this case, is a local minimum. Okay, right? And since my function is decreasing on either side of x equals 0, f of 0 is not a local extrema at all. All right, so now let's do a new problem. Example 3, we're going to use that first derivative test to find any local extrema for this function g of x. Step 1 is to differentiate. Okay, so here's g. We love taking the derivatives of polynomials. G prime is 3x squared minus 12. Step 2 is to find the critical points. Right, and that's where x values where g prime is 0 are undefined. So no domain restrictions. So there's no critical points there, but we do have an x value such that g prime is 0. Let's factor out that 3. And that's a difference of perfect squares. So our critical points are from here and here, x equals 2 or x equals minus 2, right? And again, what these critical points are doing is they're dividing up my domain into, in this case, these 3 intervals. You know, x values less than minus 2, x values between minus 2 and 2, and x values greater than 2. And those are the places where there's only one of two options. Either my first derivative is positive or my first derivative is negative. So now we're going to go ahead and do a sign test on f prime. Sign just means positive or negative here. And I'm dyslexic. Hehe. And I like looking at f prime in factored form. It helps me get the answer on whether or not that function is positive or negative on a particular interval in the domain a little bit faster. All right, so however you want to organize it, I'm going to put my intervals here. I'm going to figure out if f prime is positive or negative. And then that's going to tell me if the function f is either increasing or decreasing. Okay. Right, so what are my intervals? Minus infinity up to -2. Pick an x value less than 2, or sorry, less than -2. You know, -10. What do we have for f prime? F prime is always 3, positive 3. Maybe I'll just even write that. 3 times a number less than -2. -2 is negative. And then a number less than -2, like -10, plus 2 is negative. So we've got a negative times a negative, which is a positive, times 3. This is positive. So since my first derivative is positive, my function f is increasing. Now on the interval -2 to 2, f prime, pick a number between -2 and 2, like 0 is a good one to pick. 0 minus 2 is negative. 0 plus 2 is positive. We've got a negative times a positive, which is negative, times 3, positive 3, that's negative. Since my first derivative is negative, my function f is decreasing. All right, and then lastly, let's change this color because I got blue on there already. How about this? X values bigger than 2. Oops. My first derivative is 3 times, pick anything bigger than 2, 10. 10 minus 2 is 8, it's positive. 10 plus 2 is 12, it's positive. We have a positive times a positive times positive 3, which is positive. Since my first derivative is positive, my function is increasing. And now, so we've basically done the whole increasing, well, we've done the increasing, decreasing test. Now we just need to interpret these results. That's the only new thing for the first derivative test. Right? So we can see here at x equals minus 2, right? At x equals minus 2, my function is changing from increasing to decreasing. F of minus 2 must be a local max. Since f changes from increasing to decreasing, at x equals negative 2, what must be true? F of, oh, and the name of this function I just realized isn't f, huh? It's g. You guys have probably been laughing at me this whole time. I'll change that real quick. Oh no, it's still recording. Sorry for my incompetence here. I was just going to go find out what this function value is, but I'll leave that to you. Since g is changing from increasing to decreasing at x equals minus 2, g of minus 2 is a local max, right? Going from increasing to decreasing, this is a local max. And then here at x equals positive 2, my function is changing from decreasing to increasing, decreasing to increasing. That looks like a local min. And again, I'll let you go find this function value. G of 2, whatever that y value is now going to be a local minimum. Okay? And sorry I don't have fancy enough editing software to edit out that place where I had dead air. But hopefully this is clear.